Welcome everybody to my YouTube channel. Today we are going to talk about robotics a little bit. Right. So I've just prepared this uh, presentation to make you familiar with the basics of robotics, to make you familiar with the parts, with the process. So in today's video, we are going to discuss a little bit about robotics. We are going to get familiar with the parts, different parts we are going to assemble. So let's begin. Let's try to build a robot from scratch. Learn the basics with me. This is the introductory part of this whole series. We will go slow. We will do slow steps, step by step build. We'll focus on the fundamentals today, on the most basic things. So what we are going to do today is we are going to build these robots. This prototyping. We are going to do it slowly. If you want to follow through something, everything will be documented, everything will be detailed under the descriptions. If you like to follow through with this whole process, you're very welcome to join me, to join my YouTube channel, to subscribe to my channel, to follow through this whole series. Right. So what is a robot? Let's begin from the very basics. Robot, a lot of people, when they think about robots, they think that they are these machines, these humanoid looking machines that they've seen in movies like Terminator or your Transformer, other movies. But what a robot actually is, it's just a machine, it's a mechanical system that have moving parts. All right. And it produces force, motions, movements. It does some meaningful task. All right. So, in order to have something physical, have some meaning about something, we have to have a structure. So, the body of robot provides that structure. The bare bones of robot provides that structure. Then we have movement that can be achieved through actuators. I will discuss about the actuator in a little bit. It's for now just uh, imagine that you have a robot and there are movements happening, occurring in it, all sorts of movements. So those movements can be achieved through actuators. There are motors, all sorts of mechanisms involved in there. I will discuss that in a little bit. Let me show you the main part of actuator first. This is a step DC motor. What it is it's a little bit different from regular DC motors. This is a DC motor I pulled out from a cordless screwdriver. So this is a DC motor. This is a DC step motor. What this thing has is this has one coil that gives you rotational motion. It can move in either directions. It have a little bit of it can resist a little bit weight. But when we talk about this step motor that I will discuss in a little bit, actually it has multiple coils, and then the input is transferred through these multiple wires in the form of uh, is it, I think it's a little bit cracked. So in the form of pulses. So it has 8 coils, I believe, 8 DC coils. So when the current is passed through one, the DC coil become electromagnet that moves this shaft in a specific direction. So what we have is with the step motor is we have a controlled movement. So you may have seen robots moving in certain direction slowly. So this one DC motor can give you at least 200 iterations of motion. One coil pulse can move this for 1.8 degree. Depends, there's other variants as well, obviously. And this motor is capable of uh, like lifting certain type of weight. This one has capacity maximum 5 kg. This is going to be a very basic mode, your actuator, to perform very basic prototyping things. It will be functional. It is not some toy, some demo. It will be an actual thing. We will progress. We will make these things into a working functional machine soon. Obviously, for the prototyping. So, actuators gives you movement. The core of actuators is a motor, mechanical core. There's also a logical core. That's I will come to that in a bit. Then we have sensors. What these sensors do is, let's use the most basic sensor. A camera is a most basic sensor. What it does is it identifies objects. So there's a obstruction, let's say 5 meters ahead, and your robot is moving. So the purpose of this providing these sensors is to sense the surroundings so that robot can perform in the real world with the actual physics. Then we have controller. Yeah, so now we are talking about the controller part. For the controller, I'm going to use this very common, very cheap, yet very potent chip. This is called ESP32. All right, what this does is, this is seen as the body. Like, there's a brain and then there's a body. So this thing, this controller, microcontroller, this controls the movements of the physical body of the robot. This controller connects a DC motor via driver. There are different type of motors. They all have different drivers. I will write all these things down in the description with proper links and everything else that you can purchase from my links or anywhere else. I'm not promoting here. This is not an advertisement. I will just provide the links so that it will be easier for people to. I will at least provide what to search for. Okay. So we have these two parts. A controller. What controller does is it's responsible for decision making and control. So when you have a robot, it's not some Hollywood character. They don't have the mind of their own. Not at least for now. Who knows about the future? I'm not sure. It is possible that they can have their mind. That's a whole different story. I'm not going to discuss about that top level stuff right now. We will discuss that eventually. So what it does is it takes the decision and it gives you control movements. For example, if you have a robot and the robot is required to perform some tasks, it is required to lift something. So this microcontroller, which is lower level brain that controls the movements of the body, actually is responsible as the body. It is called as the body of the robot. If we have to lift, let's say, this external SSD, so it only applies a specific movement, specific task. So the controller is responsible to give these signals to motor, to other parts, to make it a control movement. And this thing, control, is one thing. We have two separate wirings going on throughout the robots. One is for the control line. You can design your robots in whatever way, but I'm talking about the most basic thing. There's a one separate control line that gives the signal to the machine, and then the power is usually separated from the logic. This is best practice. So for that power, we are going to use our computer SMPS for now. We will invest into a battery pack later on to keep things more modular, more simpler, right? Then we have software. So in order to interact with the robot, we also need a software platform. That is going to be a laptop or a spare phone that I have. It's an Android phone, or it can be through an external SSD that I have installed Ubuntu 22.04 already. Actually, I wanted to keep everything modular. So I thought, why not keep the SSD external as well? It will be swappable easily. You can clone this to make replicas, and if this thing is failing something. So just to keep these things in mind, right? So what software does is it gives commands to the controller. Software and operating system based laptop is seen as the brain of the computer. Controller is a microprocessor or this microcontroller based. So computer gives command to microcontroller performs the task. It's something like that. Then we have this core principle of robotics. This very basic level stuff I'm talking here. I'm going to confuse you with the higher level stuff just yet. So what is the core principle? The core principle of today's modern robots is to have interaction with the surroundings, the physicality, the physics of the reality. So we need to identify, we need to sense. Like we have senses, five senses. Some say we have six senses, but we have five senses. So these five senses are there so that we can see what is in front of us, to taste, to smell, to feel, all sorts of things. So in the same way, we have sensors for these things. So what sensors does is the inputs. Uh, let's say we have a camera attached to our robot, and it is identifying an object. So it is inputting that object through camera sensors. Then we have buttons. They are on off button for safety. They are on off button. There are other buttons as well. So those are seen as sensors. And then we have sensor for temperature, pressure, this and that. Depends on the type of robot you are building. I'm going to build a linear actuator first that will perform a push and pull motion. All right, and then we will add to push and pull motion in our robot is required for the limbs. This give like this humanoid looking robots can have this push and pull to move. There's also other type of specific type of movements that can be achieved through different mechanism. For now we are going to build a linear actuator for push and pull motions. So they sense, they can think through controller and logic. Logic is the command that we give from the computer. The controller is that actually performs the task, that tells the motor to spin in certain way, stop, to reverse, to move a certain part in certain way. That's the controller part. The high level logic is in the computer. So act, the controller is giving the command move 5 steps. So it activates the motor. The robot takes 5 steps. It's like that. Even the simplest robot follow this. All the robots in the world, they have this basic functionality capability. They utilize these capabilities to build upon more and more robots, like to give more and more functions to your robot, or to upgrade and all stuff. So what is an actuator? Actuator is actually this machine. That is what we are going to use. If you have ever used a CNC machine, if you ever used a plotter or a 3D printer, you are probably already familiar with this thing. We're going to build this thing first, and I will show you in a little bit how we will utilize this later on to our actual robot. We will build modules and then we will connect those modules. I will do this on the live stream, obviously. So what is an actuator? An actuator converts energy into motion. Common types: DC motor rotation. So they are rotating actuators. Then we have stepper motor precision steps. Motion can be linear, can be rotatory, can be directional based. There are all sorts of mechanism available. So to achieve those rotation, we have these different components. They create different force that can be controlled by the design, and that force, that design is used for different tasks. So common types of motors are DC motor. Like I showed you before, this is a simple DC motor. It spins in two directions and does not do much. Then we have stepper motor. This motor actually has a lot of control. It has 8 coils, if I'm not wrong. And what those coils are, they can make this to have a single rotation in any direction. I should probably not do this. And also there's control. It can actually handle lift at least 5 kilograms of weight, like lift and hold without power. Like it can lift and then stay in a stationary position. So depends which electromagnet is activated to perform that. By using this motor we can have 200 degrees of control over the movements of this motor, right? So there's these electromagnets that gets activated via these 4 wires, colored wires. They create small electromagnet when the current pulse passes through this, and that pulse can control the motion in whatever way we want to. This motor actually it does not run on its own. In order to run this motor we need the motor drivers as well. So we have this motor driver. It will be mounted on a different power circuit board that will be connected to your ESP32 controller, main controller. This is the main controller. These are the controller for motors and different components. They all will be connected with this micro controller using these pins and other mechanism. I will show you everything, obviously. Then we have servo motors, position control. Like for example, in the shoulder joints of a robot, people usually use these servo motors. Then we have linear actuators. So we are going to build this linear actuator eventually. So in our build, stepper motor, threaded rod. We have this threaded rod. It has these threads in it. So what we are planning to do is, and what usually people do is, we have this connector. We connect this connector through our like this. I will obviously put it in a better way. And what it does is it rotates this, and this thing is connected with something. So the rotation is forward and backward. So this is very basic movement and very common. And this movement can be applied into a useful work. Then we have stepper motor plus threaded rod equals to linear actuator. We also have these supporting rods, these smooth ones. What these rods do is, these smooth ones, they provide the structure, like we can see here, to the actuator. What happens is these motors, they're very powerful, can lift up to 5 kilogram of weight. So these powerful motors, they require a proper load balancing, force balancing, so that they won't break the whole this contraption, what you call it, and so that we will have a useful function. So we need these two additional rods. So how our actuator will work, this is a proof of concept for now I'm describing. I will start to assemble this thing in the next video, next live streaming live. So what is stepper motor, uh, how our actuator will work. The stepper motor rotates in steps. It will rotate in a certain way, backward, forward, depends what will be the command for that. Then we have threaded rod, converts rotation, linear, back and forth, push and pull. Then we have brass nut. This brass nut, this is the most important part of this whole actuator. Actually, this actually gives the whole movement to this machine, specific prototyping. So brass nut moves forward and backward. It does really fast, not this slow. Smooth rod, bearings guide movement. So we have these bearing guides to keep the movement smoother so that it can move back and forth really smoothly, really fast, right? So we have these bearing guides. So the result will be controlled, repeatable motion. We can repeat the motion, it will be controlled. We want how much we want this to move. The displacement will be through control mechanism. Useful for arms, lifts, sliders. People can use them in like uh, have you seen this, what do you call this thing that lifts a car? The word is skipping my mind. Okay, sometimes this happens. So, or like if you have hydraulic press and all stuff, so they have up and down motion, but that is a whole different mechanism. It is something like that. You can use it horizontally, vertically, in any way form. Uh, that gives some meaning to your motion, that perform some task, have some work done. We're talking purely in physics today. So we also have these mechanical parts. All these things are called as mechanical parts. A robot has a logical part, that is usually your commands, your robot brain, that is an actual computer, be it a phone, be it some other type of mini computers, this and that. Then we have uh, your electronic part, wire, cable, this and that, that we connect, battery pack. All right. So we are going to talk about mechanical parts, right? A little bit here. All these things are called as mechanical parts, right? Okay. Motor even is partially mechanical, partially electrical. So yeah, this is also mostly mechanical, but it runs through electricity, so it's also electrical part. Then we have these couplers. They are used to attach this thing to give it a rotation, and so that this thing can move. This will be more clearer when I have something functional that I will do in the next live stream. Handle load. So the purpose of mechanical part is hold everything aligned, reduce friction, handle load. Our approach is no permanent design, bolts, clamps like this. We will have bolts and clamps. This is a box for your shoulder movements. There are different type of gears, planetary gears, other type of gears, specially designed gears that give you more and more control. We will use the most basic ones for this prototyping. Bolts, clamps, brackets, cardboard, temporary frame for prototyping, mechanics first. So we will build something that functions. Even in prototyping, we will lift a little bit weight, 1 kg, half kg, or less than that. So that will be something meaningful. It's not just some lecture here. There will be practical and there will be proper explanation for that. So then we have electrical part. Electrical part is ESP32, the microcontroller. We have this stepper motor control, this driver, the stepper motor itself, NEMA 17, NEMA 17, 5 kg torque lift. So it can lift up to 5 kg. But we are not going to use this much. We will use the lighter ones because we want this thing to be more demonstrative, not like demonstrative in a functional way, in a practical way, but not some performative. We are not going to perform some tasks just yet. These are the things in the future. This is the stepper motor driver. In this case, we are using DRV8825, very pretty standard for NEMA 17. Power supply, once again, this will be a computer SMPS or PSU. Then we have wiring. For now, I'm going to use these regular home wiring wires, and later on we will do color coding and all stuff. I will just put this thing together real quick in the next video to just give it a test, and later on we will put the things properly with proper wiring and all stuff. Why drivers are needed? The drivers that I showed you, this thing, we cannot connect motor directly to this. We need a driver to handle the current difference, because motors, they draw a lot of current, and our ESP32, it operates on minimal current, and voltage is even 3.3 volts up to 5 volts, I believe. So motors, they fluctuate when they run, stop, so this can burn out our controller board. We don't want that. It's not that expensive, but still safety is, we don't want to keep buying these electronics parts. So ESP32 cannot power motor directly. Driver handles current and direction. So a controller is as important as this specific driver. There will be multiple drivers that will be controlled by this ESP32. We will do it step by step, module by module, video by video. Okay. So let's talk about software part. Software responsibilities. Tell motor when to move. Tell motor how fast. Tell motor how far. So there are two type of software part. First is low level, that motor steps timing, that is controlled by ESP. And then we have high level logic commands later. So low level is this ESP32. We give one command to this one at a time because it does not have a lot of memory. It has a good processor up to 232 megahertz, I believe, if I'm not wrong. It does not have a lot of memory, 8 MBs or something. So this is by design, this is not a fault. So we don't keep the logic with the robot. We keep logical parts separated from the robot. So in case if it malfunctions something, we have this mechanism inbuilt. We can remotely turn it off, or we can power off the supply, the emergency power switch for these, not because it can cause something. It won't destroy itself. It won't act weird, burn itself, overheat something for that. Then we have software. So as the software grows, as we are going to connect different modules, different components, different parts, the hardware will grow, and with that we will have more and more software part on our computer systems. That computer system will give different components for different parts to this microcontroller. Mind, body and mind concept, this is exactly what I told about. So usually this microcontroller is seen as the body. It controls emotions, it controls the motors, it controls the shaft movement, this and that, through different mechanism. So this is seen as the mind of the body actually, but in short people call it body, because we have an actual mind that is the main computer that we are going to use, either a laptop or a old Android phone did not work, did not test with uh, iPhone or anything. We will use Android on an external drive with Ubuntu 22.04 LTS version installed. One little point I want to make here. So when we install Ubuntu, a lot of people prefer Ubuntu, and that's the proper operating system, by the way. This can be done by window. I will use Windows and Ubuntu both in parallel, as well as Android with some special applications. But this is my personal experience. Ubuntu latest operating systems, it's rare, but still not like it's a possibility. So Ubuntu operating systems, what they have is the latest version. They can have bugs, and just imagine you are using operating system that is buggy, and something broke, something failed, and it's controlling your reboot. You don't want that. You want to avoid that. So don't use the latest version of Ubuntu. Use one less than the latest most. That is more stable. That is less headache, because this thing is going to become a headache in the future. Right. Secondly, I want to explain one more thing. When we power on this ESP32, we use regular mobile chargers. I have this Asus one, Asus one, how people say. So this supplies only up to 5 volts. We don't want these advanced ones, these 20 watt and 5, 10, 15 with PD chargers. We don't want them. They will burn your board real quick. So this is a safety measure you have to take. I will mention it in the description as well. So body and mind concept, why we separate these things, why we don't make it or mix it in just one. The main reason for this is to think of robots as body, mechanics plus motors. Okay, so motor and mechanics, they're separated from the mind. We can integrate this thing, that's a later part when everything is matured. We have built something controllable, manageable properly, uh, like uh, testing and everything else. We can merge these things into one as well. But for now, we are going to keep it separate. Mind, controller, logic, mechanics, and bodies. Mind is actually the laptop that will give the commands. We can use Raspberry Pi in the future. We can use Android phones, they're very powerful. We can use other boards as well. There are different type of different mini microcomputers as well. We can use even NUCs, NUCs, these mini computers. They are very powerful. We can use them as well. Separation matters. Body can change, mind can be upgraded. So the main idea for me to build this thing is to keep everything modular. I will keep everything modular. There will be no one continuous part. There will be always separable parts. So mind body can communicate to the common channels, but they will be very distinct. This is very important. Controller's brain hierarchy. We are using multiple levels. Lower level will be ESP32, and this driver, this very machine level, this intermediary between computer and your lower level. This is basically, it just tells how much current for how long. This one tells that what to do with your current and all stuff. And this thing gets commands from an actual computer. It's laptop, phone, something. So ESP32 low level controller, motor spins, pins timing, PC laptop mobile, high level brain, logic, UI, planning, AI later. So we are going to make this a AI robot. We call it physical robot to perform specific tasks. Since I've said AI robot, I'm not talking about all these Tesla robots or your what's that company? Dynamics, Western Dynamics, I think. No, we are not going to make such complicated machines. First, we cannot make that machine at home. It's really cumbersome. There are teams, they are involved to build them. No, we are going to use AI. So we interact with the AI, and AI will perform, will create some commands for a microcontroller. Microcontroller will perform that. We will get a feedback from that. Feedback will be communicated to us through AI. So we are going to integrate it like that. I'm sorry. This keeps the system modular, replaceable, scalable. So the main purpose for this is, which is very common, everybody does this. I'm not doing it specially. This is a very common practice. Replaceable and scalable. So we will keep it modular. If something burned, that will eventually happen. We can replace it without disturbing the other parts, other flow. Replaceable for the same reason, and scalable. If we want to upgrade it in the future, we want more force in our motor, we want to perform an additional task, we can scale it according to that as well. So we have this ESP32 microcontroller. This is the main character of this robot, physical AI. We have the reason why I picked this. We can do this with other chips, Arduino, and even Raspberry Pi Zero, which is the cheapest, most computer available. But I picked this one because it is very cheap. But cheapness is not the main constraint. It is actually very powerful. In today's time, a lot of 3D printers, in conjunction with other parts, other electronics as well, obviously, they use these things. The specific chip, this is a European chip. So it's very common, very, very common. It is everywhere in today's time. So don't just let the cheap part confuse you. It's very powerful enough to control a lot of things. Main reason for me to pick this is it has inbuilt Wi-Fi and Bluetooth because I wanted my robot to be remotely controlled. It has huge community, means more documentation, more. Just imagine if you bought some random chip, it is not properly documented, nobody is there to help you, it becomes a pain in the wrong part of your body, right? So ESP32 role in this project is to control motors, basic decision logic, interface to higher systems. Let's look into this. I'm not going to describe all these things, just giving you an overview of this. So we have this positive terminal, we have this, these things can be performed through these chips. We also have these functions with these two buttons and a micro USB controller that can be controlled through the IDE. We can use commands to get this thing perform specific tasks. Then we have tasks, this grounding, we have IO pins, we have SD pins, we have all CLK clock one. We have all these pins. They have specific they are utilized in a specific combination to perform specific things. Optional space for this is, and when we have LED, LED is to notify you whether the chip is this controller board is on, or is Bluetooth on, or it is communicating or not. Very useful when you flash and all stuff. So motion control, basic decision logic, interface to higher systems. Parts we currently have, core components we have, like I showed you just now, We have a ESP32 WROOM model, or room model, or how you say it. We have one of this microcontroller. We have a motor driver, DRV8225. I will write this down if you want to follow through with me in the future, or you want to follow through later on. You can find it in the description. It's not an advertisement. I don't advertise this. I'm not doing for anybody. These are just generic parts that are pulled from the internet, from the random shopping market, online markets. Okay. Then we have NEMA 17 stepper motor. This has 5 up to 5 kilogram force KFC. Then we have threaded rod with brass nut for our actuator. It will perform the movements. It will give the direction to the force. Then we have smooth rods to give more structure to our actuator, to make the transition more smoothly. Then we have linear bearings. We have these things. What they do is they go into this like this, so they make the transition very smooth. That's and fast. So that's the purpose for these. Very common in 3D printers as well. Motor bracket. We have a motor bracket as well to keep everything in place. All right. Shaft coupler. So this thing is called as shaft coupler. And we're going to use this shaft coupler with our motor, and this will be rotated by the motor. All right. And then we have wires and power supply. Power supply is once again going to be simple PC, SMPS or PSU unit. That's the best option we have right now. Later on we can use battery packs and all stuff. What we can build with these right now, we can build a linear actuator. That's the main goal. That's the main goal. That is what I'm going to do in the next live streaming. Single axis movement. All right, back and forth, push and pull. Motion testing platform. Later on we are going to use this as we progress throughout the months. We can build multiple actuators, make them to perform things simultaneously, one after other, depends. Robot torso, arms, sliders, tools. We're not going to build this limbs, legs for right now. That has a whole different complexity. So we are going to avoid that. We will mount it on a table or on a plate, on a wooden plank or something. We will see what this robot is not. This is more important. Not a finished robot, not a humanoid yet. We will decide whether we want to make it human looking or what we are going to do with it. Not AI controlled. The machine will do the command, will give the command to the microcontroller to perform tasks, and usually I will give it. It will not be automated. At first, the prototyping will be like this. We will advance obviously slowly for the future, in the future. Not optimized yet. So it is just bare bone structure to have a proof of concept. Not something very complex. Sorry. Not something very complex, very flashy, this and that. No, we are just dealing with the bare bones. It is a learning platform. So if you are interested into robotics like me, you can join, you can share, you can come to live streaming, you can discuss with me. We can discuss offline as well. A real prototype. It will be a real thing that will actually perform tasks, but it will not be a specific task specific real life thing. It will be a prototype that will be able to perform the tasks. That's it for now. A foundation just for the learning, to have to become familiar with the fundamentals, basics of a robot or robotics, because this is going to be a very big thing, and I believe everybody should know how these things actually work. And if you are going to learn something, you are going to build something, that's also a whole different thing. Otherwise, watch it as an entertainment. A lot of people say that my voice is very soothing, so you can use it as an ASMR. Depends upon you. Right? How this series will progress? Start simple. We will start very simple. We don't have big flashy things. We don't have store bought, because all these things they exist on the stores for expensive price. We are starting from the scratch. That means we are building our stuff with the parts. We're not buying stuff from the outside. Actuators, all these things exist, but we are going to do it step by step so that you can learn it properly, you can integrate it properly, and understand the most basics and fundamentals of robotics. Test each part. This is most important thing. Testing is very important. We just don't just assemble something and expect it to perform tasks. There will be like failures. There will be like sometimes something burns, sometimes something does not perform what we want to perform, wiring this and that. So testing is very important. We will improve slowly. We will replace things. We will try to figure out what mistake we made, why this thing happened, how to prevent it, all that stuff. There's a documentation for this as well. So we will take help from documents as well. Add complexity only when stable. So this is very important. We will test it and we will add more and more parts, make it to perform different functions slowly. So this is going to be a long project for weeks or months, depends. Build, test, understand, upgrade. So we will build and then we will test. And I will explain that what is going on. And then we can upgrade if we want to in the future. So we have reached to the end of this live stream and today's topic. So the goal is understand robotics by building it, not talking about it. We are building the robotics. We're not just going to talk about it. Today I had to talk about it a lot because fundamentals should be clear. Next step will be assemble actuator. In the next live streaming, I'm going to assemble the actuator. Power it safely. We will try to turn it on after assembling and move something. We will move a small object, maybe a pen or something very small. Maybe this USB drives. We will see what we are going to do. So stay tuned to my YouTube channel. You want to subscribe, you want to learn robotic basics, you're very welcome. Subscribe to my channel. If you want to discuss something about these things, you can leave a comment. You can discuss through live streaming. It's up to you. Yeah, so that's all for today. Let's stop here. I will be back in the future with more advancement, with more parts, with more assembly, with more functions. Will be less boring, I believe. Okay. Yeah, so let's stop here. Thank you so much.